In other equation, let's say this is 0. Maybe this is 10, 100, 1,000, maybe 10, 20, 30, 40, 50, 60, 70, maybe something like that. Hindi ko pang mga ano dyan. So if this is 10, meaning to say 1 sarong guhit, kung ito 5 guhit lang, siyempre equivalent isang guhit is 2. So it will be difficult to read in between 2. You know? So you set the range somehow. If this range 220, nandito lang siya yung layan. Yung layan. So if you set the range to let's say this is in the range of times 10. If you set the range of times 1, mag-iiba ang ano mo. So, maybe this is. So, ngayon, maybe ito na yung 10. 1 and dalawa na, nagbago ng range. That is why if you want to see the most accurate value, you lower the range because yung pinakita niyang 220 dito kasi baba. So if you set the range to 200 to 50, and the maximum range here is actually maximum range is 250, maghiling mo na ang deflection na nasa labas na after the so yeah. So, you see, it's still within the range. Hindi pa masisira ang meter. Yeah. Anyway, one thing to be avoided with this instrument, this analog instrument, is to switch this, to transfer this, to change the range while it is connected to the source. Kasi during the transition, there can be spark. Ang nasa loob yan, yung mga switches lang, may demonstrate na ito. So, yun ang precaution ito. What if you are mistakenly set the range to DC? Magre-register ba? Most likely, it can give you reading kung nakasala ang DC. But that is not going to give the accurate result. So, the same way with the DC volt, maximum volt, you put it maximum. Pero kung battery ang iyong i-measure, you expect that the battery is always rated to 1.5 volts. So, itong mga battery, this is size C. Tapos sa mga battery na rin ganit, even the small one, ano ba yung maliit? Even the small one, this reads about 1.5 volt, 1.5 volts. So, if you will measure the voltage of this, you will set this maybe 2.5 volt will be safe. Let's see if the battery is still alive. Hindi na siguro. Tinakla na. Tagal. Actually, this needs 6 pieces. Nasaan tayo yung isa? Okay, so somehow this is still alive. This is set to 2.5, so 2.5, so still this gives us about 1.6, about 1.7 volts. Most likely the meter is not calibrated. Say low, most likely this is going to be the actual voltage of lower than what is being displayed. So ito, hindi mo siya pwedeng gamitin sa accuracy with precision work. Kasi ang accuracy niya ay mamamali ang ginagawa. Okay? So with the resistance, measuring resistance, you set the range to like to the specific range where you expect the resistance at its highest value. In this case, the value is only times 1, times 10, times 100, and up to 10 times 10,000 kilo ohms. So when measuring resistance, you will see the scale. The resistance starts at yung maximum at zero deflection. The maximum resistance is at 2 kilo ohm. Actually, the lowest resistance is the highest resistance here is infinity. So if you put a resistor to measure here, that's the time that this meter will deflect. Now, if you are going to measure a resistance that is lower than 2000, you set again the setting to a lower range. So, ang maximum range niya is 10K. If you will be measuring 1,000, or maybe less than 1,000K, you will just set this maybe to 1 times 10. Times 10 of the value here, that's the resistance. Okay. So, being this is analog, you will see that the resistors you are measuring will not always fall in the same value. Okay. Kung ang graduation niya ay napakalaki, maliit, kaya niya sukatin yung maliit na reflection. Nakikita mo ang accuracy ng value na sinusukat mo resistor. Okay? Now, in measuring an ampere, you actually, but by the way, there is no problem in measuring for a DC, or to measure an AC, there is no problem if you put the line, may tumagang may red, black, red, okay, may black, may red. There is no problem in putting the probe to any of the line if that is AC, because AC is always going to give you a deflection on a positive direction. On positive direction on the meter, it goes to the right. On negative direction, it goes to the left. Now, if this is DC, be careful to note first which one is black or minus or the positive. Because if it turns out that 0 to 12, the baliktad, tendency of the pointer is to go to the negative direction to the left. So if this is negative black, this is negative, this is positive, the meter will fall towards the positive direction. If you reverse this will tend to go in the left direction. In this case, pwedeng hindi masira. Pwedeng hindi masira kasi kayang-kaya niya i-compensate yung ohms niya. Except that, over time, na ginagamit mo ang negative deflection, na-strain ang screen. Hindi kaya igwain yung screen. Every time na na-strain yun, mag-calibrate ang reading. So next time you use it around, maybe it will reflect more than the value that it reads. Kasi na-strain na. So this is ito ang critical sa. Now, in all this, measuring voltage, okay, if you measure voltage, when you measure voltage, you actually do not use any source of power for the instrument, because the line which you are actually measuring already has power. It's only when measuring resistance that you need extra power, because a resistor has no source of power. Okay. That is the reason why the voltometer contains battery. Yung battery lang. Yung battery niya, kung marao, total barato man sa lahat. Just to show you. Basta, ano mo, pag sintabo ang pinag-ulayan, pag nag-isip ka sintabo, pero yung isip mo, barato sa na yan. Pero sa na barato. Kapag nag-isip kang mahal, ay mahal. Ang isip mo, problema. Pero barato lang yan. Mura lang.
Mindset ba? Mindset.
Na bakalan daw nga yan sa kanan. So, this is powered by my battery. Dalawang battery lang ano. Dalawang 1.5. Si ibang meter, makahiling ka dyan yung parang rectangular na battery. Yung rectangular na yun, 9 volts yun. 9 volts. May mga calculator noon na 9 volts. So, yan ang law niya. So, if you take a look at the content of the mechanical assembly of the dial, it has nothing but a coil inside, a coil, at saka yung may spring. At yung terminal na dalawa, yung wire. Mamaya i-draw natin yan. So, hindi kaya buksan. Anyway, that's why inside there is a fuse. Kapag nasa ka, di mo tulong sa pagtapok. Sila na. Buksan mo muna, hilingan mo, tertibaan kung may putok lang yung fuse. Okay, dito ang putok ang fuse. Huwag mong papalitan ng hindi pagkaparehas na rating. In this case, I think the ampere of the fuse is only 1.5. Walang rating. 1 ampere yan. It's rated to 1 ampere. Ang iba, kapag pumutok ang fuse, bukwasan ng wire, pag nandiyan. Pwede yun. Magkano yun. But if you are mistaken, lahat na masisira. Hindi lang fuse masisira. Mas kasarong mo, naputok ang fuse, sabi mo, ikikagal sa pasang-pasang pag sigarilyo, kita. Tapos pag nag-plan sa mga ito, nag-uusap na. Susunod pati. Okay, so, ini ang ano. Okay. So the way this instrument works is that this is a coil of wire. This is a coil. This is a coil of wire in which there is a terminal, one black, one red, and then this is suspended by a spring. Okay. This is a permanent magnet, north, south. So there is a magnetic field always present in the instrument. Sabi natin, if you inject a positive current, tendency of the tendency of the coil is to produce magnetic field. It's actually going to produce magnetic field. Such a way that this magnetic field will tend to align with the. So, depending on the intensity of the current, that will be the deflection of the voltage. So, kung mataas ang current, mataas ang deflection. So, this coil has resistance, so that this resistance will only be able to admit certain amount of current. Now, to be able to multiply this current, often this is placed in here. This is what you call your bridge. It's called bridge. Oh, it's called bridge. Ito na ngayon, equivalent, parang nandito yung meter mo. Okay? You will see that if this is powered by a battery, and this is the lower battery, you will be able to divide the voltage in between the bridge so that you will be able to get a smaller value of voltage across the board. So the actual voltage here is not translated immediately into the coil, but it is being divided in between the resistors in the bridge. Okay? Now, to make a realization now of itong switch, itong pointer, meron siya ng access. Parang putulin natin ito. Ito natin. Okay? And we can now divide this. This is na your selector switch. By moving, let's say this is times 1, times 10, times 100, times 2,000, 1,000 K, times 10K. By moving the switch, you can select the range by inserting a dividing resistor. Pag-abagan natin, when you put this resistor in series, it divides the voltage. So if you want to select the highest value for you put a resistance that is higher value, so that the same current will take effect into the coil. Now you select the range because you actually cannot change the capacity of the coil in the meter. Hindi mo mababago ang capacity na kung ano ang rating, anong resistance ng coil, anong current rating, anong voltage rating, yun na yun, yung mababago. So para mabago mo yung sa labas na lalagyan mo siya ng interface, ito yung kasama. So in a short diagram, ini ang diagrammatic interpretation ng content ng analog meter. It's nothing but a resistor. It's nothing but a voltage divider, a divider network with the bridgestone as a circuit that defines the magnification of the range. Okay. So whether it is used in AC or DC or in milliampere, measurement milliamperes. The same effect will be. Now the question, since this one is only capable of measuring 250 milliamperes direct current, can I be able to measure more than 250? Huh? Pwede? Pwede. Ato ba sa daya? Okay. Anyway, how do you use the instrument in measuring this? Sabi natin, this is to measure the current must be, the probe must be connected along the line. Okay? To measure the voltage, the terminal should be connected across the line. So this one is across the line. The ammeter is connected along the line. Along the line because the current passes through the line. While the potential difference exists between the lines. So line 1, line 2, state the voltages. Okay, that's why. Now the question is whether I can use of the small 250 milliamperes. Kasi what is here, what actually is present here. Kung itong circuit ng voltage divider present dito sa BOM ay in order to select which multiplication of voltage division will be present, here in the ammeter, ang selection mo ay ang selection ng switch mo ay parang, if I can imagine, try to imagine this is a slider, okay? This is a slider switch, which is connected to this one, so that if you put this here, this is will be times 1. And if you slide it further, this will be times 2, times 10. If you slide it further, ano ba tama dito? Okay. At first slide, this is 50 microampere. The second slide, this is 2.5 milliampere, then 25 milliampere, then 250 milliampere pag sinaslide mo dyan. Wait, what is the difference between this and this? Here, it is the current that is being divided in the resistor. Current, that's why here this is for circuit for current measurement. Here, this is circuit for voltage measurement. Yan ang pagkakaiba niya. Kasi yung current na dumadaan ay i-divide. This is the current being measured. The maximum is 250 milliampere. If that's 250 milliamperes, the first current that it might encounter is this 250 milliamperes, then 25 milliamperes, then 2.5, then 50 microamperes. So, pag dito muna, 250, pag dinagdagan mo, pag binawasan, so on. Okay? So, yan ang pagkakaiba ng. Therefore, kung gusto ko palang sukatin ang 10,000
if I have to measure more than 1,000 volt, pwede pa lang. I just have to compute for the constant of the meter and then insert another resistor here. Imbis na dito, lalagyan ko ng another resistor. Ay, lalagyan dito, punta dito. Ano ibig sabihin yan? Kung more than 1,000 volts ang i-measure ko, ito, magkukuha ako ng resistor, ilalagay ko dito, dudugtong ko dito, at so in between the probe, lalagyan ko lang ng dividing resistor. So I can now measure a voltage that is higher than the range. So in the same way, current can be measured higher than the rated by putting a shunt resistor here. This is a shunt. Shunt resistor. And this follows the same principle as the internal circuitry of the meter itself. Parehas lang. So pwede. Oh, okay. Anyway, what you need to know is just know first the characteristic of the meter. Itong mga pinapabakal ninyo, walang data. Kung mabakal ka mga industrial grade, yun naman sa specification. What is the deflection of what is the calibration of the meter, maximum deflection, error. Ito wala. Talagang pang pasa nito. Marami kaya. Okay. So any question on the voltometer? Now, principle here is practically the same. The circuitry that is introduced in the BOM is practically the same. What makes a difference is the additional clamp that is used to probe. That is a probe to use to probe the current present in the circuit. In the previous instrument, you notice that the probe is connected. There is a physical connection between the lines. In this case, wala. Ika-clamp ko siya dito. So kung ito ang line, ika-clamp ko siya. Ika-clamp ko yung line. Papadaanin mo lang yun. Ito yung linya. Ito yung linya, ika-clamp mo lang. So you will be able to measure the value of the current. Current ang mag-measure mo. Kung voltage ang mag-measure, kung gusto mong sukatin ang voltage, gagamit ka ng itong probe nito. Kung voltage, kasi ang voltage you measure the voltage across the line. So ito gagamit mo dalawang terminal across the line. You insert it and then first set the range. In this case, the AC volt is only 750 volts. 750 volts. And then you can start measuring the value. 750, 300, 150, and that's the maximum of the AC volts. So you can proceed. Wala tayong probe na lines. Okay, so you can proceed with the measurement. Now, by the way, when you are no longer going to use the instrument, set this to walang calibration. Meaning to say, naka-off siya. Kahit gamitin mo yung walang pupuntang current doon sa pointer, sa magnetic coil. Kahit nisaksak ko yun, ngayon and then, because you are expecting to transport this is ilalak nito. Kasi mag-hero siya yung kasi kung nag-transport ko sa yung hero, pwedeng ma-derail ang so ilalak. Pero grabe ang kahit nila nagkabarasag-basag na. Gusto kong gamitin to kasi this has become part of my profession. This has become part of my life. You see, this belongs to the ComSat Systems Division. ComSat Systems, this is signatory of the American Space Agency, the NASA. When they launch satellite, when they're going to launch a spacecraft, the ComSat is always there to move. Sila ang nagbibigay ng telecoms. One time I become part of their company. So this is one of the instrument na yun. Kaya pag nahihiling ko yun, pupunga mo ako. Okay, how is this instrument working? Actually, this clamp is nothing but an iron. Yung dinidemonstrate ko na natin sa laminated core, laminated. Yung plate na pinagtabi-tabi, tapos pinawang, yan. This is the magnetic part. Ito yung kanan ng magnetic field, yung ferromagnetic material. So, sabi ba natin, when a wire carries current, it carries with it an induced magnetic field. There is this wire goes to be carried like this. If you follow the right hand rule, there is a magnetic field revolving around. So this magnetic field that cuts perpendicular to the direction of the wire will flow into the magnetic core. Itong core na ito, papasok dyan, pupunta dyan yung magnetic field. And that magnetic field, dito sa loob, merong coil. So this is the magnetic circuit. Ito mayroong coil dito. Itong coil na ito, itong pupunta, mag-generate ng voltage. Dadalhin dito sa point there. So the same, except that the power that is generated going into the pointer or the coil is derived by induction. It's derived by the induced electromotive force produced by the magnetic field around the wire that is captured by the probe. Okay, so now another question. The maximum range of this is 350 amperes. Maliit lang ang ampere. 350 is nothing. So this maximum range is 350 amperes. Okay. Now, kepuan ko naman sa field. Ano mo kung measure 2,000 ampere expected maximum capacity. How am I going to make use of the paano ko talaga susukatin kung 2,000 yun? Kung 2,000 amperes talaga, dapat mahiling ko ang eksaktong ampere. Kasi the reason why you need to understand the current in the circuit is to be able to provide the safest protective device. Sa circuit, ang pinakaunang tinitingnan pagkain ng pinag-uusapan ay yung protection. Because if there is a short circuit, that short circuit can immediately be arrested. Mamamatay ka ng circuit. Especially, di ba may nakita ka ng fuse? Yung fuse, pag nag-overcurrent, puputok yung fuse para hindi na masira yung iba. Now, the question is, paano po gagamitin ng 200 maximum 250 range sa 2,000 amperes na? Okay? So, what you will do is, if you expect this current is 2,000 amperes,
approximately. So what you will do, if your instrument is only 350, if you divide this by 350, that goes to about 1 plus about 6, 7, okay? About 6, 6. So if that is 6, you put 1, 2, 3, 4, 5, 6, maybe 7 wires. 7 wires. You expect that if determination here is tight, rigid, the current, the 2000 amperes will divide among the wire. So ilan yan? Ilang wire ampere dito? Pwede mo na gamitin. Measure here, how many current, how many ampere, how many ampere, how many ampere. So this, plus this, plus this, plus this, will be the total ampere. Pwede. So, hindi limitation na, hindi mo pwede. Sayang, hindi natin ito mo pa ang gagawin ko. Pwede siguro. Look.
Power meter.
Speed of flow. Made in Poland. About 45,000.
Woo! Swel, duhang bolang sweldo.
Hindi nag-survive yung battery. Namatay na. Yeah. Now, anyway, hindi mo ma-survive. Kasi pag-andaran ako na lumamasit ang electric fan. Para mahiling kasi pagkakaiba ng waveform. Mahiling ang pagkakaiba ng waveform. Sana mabuhay pa. Anyway, this is volt, ampere, and watt. Now, in the other Newton, you will see, you can either see the display kung ang waveform ay, kung gusto mong tingnan yung waveform, i-press mo ito. Kung gusto mong tingnan yung value, yung bar value, press mo ulit. Tapos kung gusto mo yung text, pwede yan. So yung makikita mo ang pwede. So if you select the graphical value, pwede mo mahiling. Okay, so yan ang mga. Now we'll see kung kaya niyang basahin. Actually, this instrument, bago ginagamit itong instrument na ito, at least nakaon ito ng 8 hours. At least nakaon siya ng 8 hours. Kasi ang instrument is very dependent on the accuracy of the instrument is dependent on the temperature stability. At cold temperature, at cold start, pag-cold na ngayon, battery. It takes some time for the electronic parts, especially microprocessor, to stabilize. You know very well that temperature affects the resistances of the circuit. So much so with semiconductor. So when it is not properly stabilized at the temperature, hindi siya magbibigay ng anyway, for the purpose of demonstration, let's hope we can
So anyway, the same purpose, the same function as the clamp ammeter. We make use of the clamp, itong probe na ito. Makikita mo ang probe na ito ay parehas lang ang clamp na ito. This is made up. This is used to capture the magnetic field around the wire. That's why when you're going to measure the ampere, you just put this in here. And then when you're going to measure the voltage,
Between.
you put this
Pareho.
voltage. Now, if at the same time, this is put across the line and then this is placed along the line, you will be able to measure the watt. Ilang watts ang kaya niya. And by measuring the watts, you can then already observe the behavior of the waveform of the watt. So listen here, you actually can hold the value and then you can change the range. You can change the range. And for record purposes, you can measure. I think there are 10 memories. Pero 10 lang ang memory kaya that you can record for that particular value. Okay? So ito ngayon ang okay? Anyway, this instrument and this instrument walang parehas ang function except that this one ang ibibigay sa iyo ay meron siyang graphical display. Sinusoid, makikita mo yung sinusoid mo talaga yan. Makikita mo, ito, ginagamit ko ito kung nagtetest ako ng generator, lalo mga pulang generator, yung mga megawatts. Kasi, i-testing yung generator, making sure na output voltage ng generator is sinusoidal. Yung mga portable na generator na nababakal mo, hindi yan sinusoid. Mayroon pa akong nahiling na portable generator na use ng sinusoid. Kadak-kadak lang mga generator na emergency generators, ang waveform niya ay yan, by distortion. Hindi siya pumapalo, supposed to be sinusoidal siya. Kaya, kapag ganitong wave ay ginamit mo sa motor, okay, ginamit mo sa motor, yung kahit electric fan, tingin mo mag-brown out, under ng generator, under ng electric fan. Kung hindi sinusoidal ang output ng generator mo, maririnig mo yung ingay ng generator, may hum. Merong abnormal na bakit nagkakaroon ng abnormal na kasi pagdating dito sa flat na curve na ito, this is being seen by the coil as a direct current. This is a direct current component of an alternating current. Suppose this is an alternating current. Okay. Take note that the differential of current with respect to time here zero. Zero, meaning to say the inductance zero. 2 pi Fm becomes zero. What happens if the resistance is zero? Infinite current will pass. Kaya, kung ang electric fan mo, ang aircon mo, ang refrigerator mo, ang inductive load mo, ang motor load, kung ang generator ay hindi sinusoidal ang current, maaaring masunog. Even if the voltage value of this is, even if the rated voltage of this is 250 or let's say 230 volts, kahit makita mo dito na 220 volts ang binibigay niya, maaaring masira pa ang motor mo. Because of the presence of instantaneous DC. Think about, even if the DC is here at the lower negative cycle, but because it is DC, it introduces zero impedance. Because the rate of change of current is zero. Okay? So, kung meron kang motor na medyo critical, hindi mo gagamitin ang generator mo. And my concern when I'm maintaining a bigger generator for this industrial use is to make sure that it produces the actual sinusoid. Kahit no matter how deformed is that, pwede pa deform niya ng ganun eh. Basta ang importante, wala itong DC component na ito lang. Ito ang very critical, yung DC component na alternating current. Kasi yan ang sumusunod ng mga inductive load. Sa mga electronic device, okay lang yan. Sa charger mo, okay lang yan, charger. Kasi yung charger naman, kung switch mode power supply, yung DC, ang AC, kino-convert niya sa AC, DC, hindi ko-convert niya ulit sa AC, and rectify it. But in this case, in motor, that's very dangerous. Okay? Now I think the last one is, the last instrument we have is the kilowatt hour meter. So this is, wala na tayo magagawa nito kasi pag binuksan tayo yan, ang manulated dyan, electronics, kasi may conductors na nasa loob. Ito lang ang interesting sa atin. So you will see there are 4 terminals. Usually this side is the input and this side is the output. So this is now the kilowatt hour meter. This is how you connect this. The 220 volt is connected to the output side, and then the output. This is in. This is out. Oh, that's the connection of that. Paano ngayon dadayahin ang soon? Yun nga yung importante. Paano dadayahin? I-connect ulit ito. Yan ang tinatawag ka. Kasi, jump, lumukso. So, the current that is being drained, has two paths. One is here, I at the meter, and here I at the jumper. Okay? So, kung gusto mo talagang kung gusto mo totally walang ang konsumo, pagdalin mo ito. That is why, kapag nakailing yung Voltohmeter, bighanap po yan mga posible na yan. Kasi pag nahiling sa ka, ipipista ka. That is my moral obligation. Why? Because I am part of those who pay for you. Yes. That's why I have to complain. And that is why I'm teaching you this. Because you have a responsibility. Pag nakita mo yung kapitbahay mo na nag-jumper, may obligation ka na magsabi. Warningan mo ako. Ikaw may jumper ka. Tanggalin mo yan because parte ako nang babayad ng hinahabol mo. Kasi yung system mo pinag-total-total, pag hati-hatiin, lahat tayo babayad. And that is the reason why I'm so open teaching this to everybody. Anyone who say, gusto mo matuto magnakaw ng kuryente? Oo, kasi ito, kita. Right away, ganito yan. Ngayon, alam mo na, may obligation ka na. Pag nakita mo yan, pag nahuli kita, ididiin kita. Kasi tinuruan kita para hindi gamitin yan na magnakaw. Para maghuli ka ng magnanakaw. Okay? That's your responsibility. Except now, because of the advent of electronics, pwede kang gumibuti circuit paggamit ng electronic device. Na ang lalabas na current dito ay phase inverted. Nagkaroon ng phase inversion, minsan hindi nababasa ng analog. Hindi yan nababasa. Ito, depende sa circuitry ng digital. Kung magkataon na ang digital is kayang basahin ng phase inversion, baka dublihin ang reading niya. Bayad ka, dubli. Kasalanan mo, bayad ka ng dubli. Yan ang precaution dyan. Pero pag hindi, baka mahuli ka pa rin. And the easiest way to test whether there is anomaly in the metering, simple way. Ito lang ang kailangan mo. Kunin mo itong current dito. 10. Kunin mo current dito. 2. Oh, may problema ka. Kunin mo ka. Dapat kung 10 dito, 10 din dito. Kasi, pag tinin mo ang circuit, yung pumasok, lalabas. Kung pumasok dito 10, dapat 10 din dito. Pero pag pumasok dito 10, ito hindi mo makikita dahil nasa loob ng bahay. Dapat, ito yung load mo. 10 din ang lalabas. 10 amperes. Kaya pag kulang pumasok dito, kung pumasok dyan, 2 amperes. Doon 10. Saan pumunta yung other 8 amperes? Ito mo. Kaya huli ka. Ito lang gagamitin mo. Ako mo sa may sarili. Ano ba sarili? Ano yun eh? Pag-ulayan na lang o ano? Sige na nga sir. Banga ngayon kita. 8 ang nawawala. 4 sa iyo, 4 mo sa kuya. Wait ka naman, bahala ka dyan. So, madali pang huli. So, with this instrument, simple as this, wala naman talaga. You will be able to. Now, when you are maintaining electric motor, yung mga darakulang motor, sa mga binabantayan mo yung ampere, output ampere ng papunta sa motor. That's why during the time when you first commission it, the first time na paandarin mo yung motor ng bago, meron kang tinatawag na test and commissioning report. bagong motor, paka-install, papaandarin mo na para paandarin na talagang service niya. Meron kang record. Ampere, tapos kukunan mo siya ng waveform, power factor. Kukunan mo siya, re-retratuhin mo pa, picturean mo, may record ka. Habang tumatagal, you will feel that there is some kind of, abnormality in the motor. You will go back to the initial record and then you perform test, present test. You compare the test. And the comparison will tell how you are going to decide whether repair the motor, replace it. So depending on the characteristic that so after the So importante na may instrument ka. Kaya lang, sa ngunyan, ang maybe nagtitipid, sa minsan sa paraan ng pagtitipid, ayaw mag-invest ng instrument. Ang nangyari, you replace the motor kapag nag-breakdown na. So, there is no more need to be maintaining the motor. Hintayin mo lang, pag nag-breakdown ka, bili ka ng bago, palitan mo na, basura mo yung natin. Mga tawag niya, yung first failure life lang ang ilintay ng walang repair. Once na nagsira yan, immediately tatapos na. Ganyan. Pero magigibo mo yan kung ang motor na minimaintain na yung barato mo. Kung sumamahalo mo, yung pwedeng dapat i-repair.